Welcome to the Deep Dive. Today we are going way back in time
Oh, yeah?
to explore the surprisingly ancient roots of science.
Okay.
You might be surprised to learn that some of the big ideas we take for granted today
Like what?
were actually brewing centuries,
Oh.
even millennia ago. Expert speaker.
Yeah.
You and I have been digging into some fascinating research, and I can't wait to share some of the most mind-blowing bits with our listener.
Absolutely. There's this misconception that science is purely modern,
Right.
but the research shows that's just not true.
Yeah.
We're going to uncover some unexpected connections and show how ancient civilizations actually laid the groundwork
Like how so?
for the scientific advancements we see all around us today.
Exactly. Think about it. We're talking about the fascinating mix of ideas and technologies from totally different cultures,
Right.
like ancient Greece and Babylon.
Yeah.
They came together and created something truly unique,
Yeah.
a civilization based on scientific thought.
What's fascinating is that this foundation in science really makes our civilization stand out.
You think so?
When you look at other advanced cultures throughout history,
Like who?
the Chinese, the Assyrians,
Okay.
the Egyptians, they didn't quite follow the same path.
That's a really good point. They might have developed impressive technologies and engineering,
Right.
but it seems like they were missing something crucial.
Yeah.
That would have sparked that same sustained scientific growth we see in the West.
It's like they had all the pieces of the puzzle, but didn't quite put them together in the same way that the Greeks did.
Interesting.
This brings us to what's often called the Greek miracle, this sudden explosion of scientific thought in ancient Greece.
Okay.
Historians used to think it was just some innate Greek genius.
Like they were just born smart.
Yeah,
Okay.
but it's way more nuanced than that.
Okay, let's unpack this Greek miracle.
Sure.
It's easy to think it was just this isolated phenomenon,
Yeah.
but what we've been looking at suggests otherwise, right?
Right. The Greeks had this very particular way of looking at the world,
How so?
logical, geometric,
Okay.
focused on visual representation.
Got it.
What they were missing was that Babylonian strength in hardcore calculations and their super sophisticated approach to astronomy using math.
Really?
The Babylonians were like the master calculators of the ancient world,
Wow.
predicting celestial events with remarkable accuracy.
So it sounds like the Greeks brought the framework,
Uh-huh.
the logic,
Yeah.
the big picture,
Right.
and the Babylonians brought the raw computing power,
Exactly.
the nitty-gritty details.
That's-
What happened when those two worlds collided?
They created a remarkably accurate model of the universe.
Seriously?
Centuries before Copernicus. We're talking about the Ptolemaic theory of planetary motion, a true mathematical masterpiece.
Wow.
Think about it. This theory predicted the movements of planets with incredible precision. That's way more impressive when you consider they didn't have telescopes or computers.
Yeah, that's true.
What's even more fascinating is how this blend of Greek and Babylonian thought played out in their technology.
You're talking about the Antikythera mechanism, right? This thing still blows my mind every time I think about it.
I know, right?
Who would have guessed that the ancient Greeks were building complex clockwork devices like this?
It's crazy.
It totally challenges the traditional image we have of them, right?
Right. We tend to think of the ancient Greeks as all about philosophy and abstract ideas,
Yeah.
but the Antikythera mechanism proves they were also incredible engineers.
Oh.
This device, discovered in a shipwreck dating back to the 1st century BC,
Wow.
is basically a sophisticated astronomical computer.
Oh, wow.
It uses dozens of gears to track the movements of the sun, moon, and planets.
Wait, so it wasn't just some random one-off invention?
Doesn't seem like it.
Are you saying there's more to this story?
Exactly.
Ugh.
There are historical accounts of similar devices built by Archimedes. So while we only have fragments, the Antikythera mechanism hints at a much more technologically advanced civilization than we traditionally give the ancient Greeks credit for.
I see.
It suggests a rich but largely lost history of scientific instrumentation in that period.
That's fascinating.
And what's even more interesting is how this technological sophistication was connected to their philosophical and scientific thought.
I'm starting to see a pattern here. Earlier, we were talking about how other ancient cultures seem to miss that crucial link
Yeah.
between theory and practice. Like they couldn't quite bridge the gap,
Right.
but it sounds like the Greeks, maybe because this fusion of ideas with the Babylonians,
Maybe.
were able to make that leap.
That's a great observation. And this connection between the practical and the theoretical wasn't just limited to complex devices,
Oh.
like the Antikythera mechanism.
Uh-huh.
One thing that really stands out in the research is the power of visual representation in ancient cultures.
You mean those ancient diagrams with squares,
Yeah.
crosses,
Mm-hmm.
stars, all that geometric symbolism? I always thought those were just for decoration or religious purposes.
They were definitely visually striking,
Yeah.
but they were way more than just decoration.
Oh, really?
These diagrams were tools for thinking,
Hmm.
for representing complex ideas about the universe,
Like what?
the elements,
Uh-huh.
the forces at play in the natural world.
Got it.
Think of the Seal of Solomon, heptagrams,
Okay.
even the yin and yang symbol.
Yeah.
These weren't just pretty pictures.
So you're saying they were more like,
They were powerful ways of organizing and conveying complex philosophical and scientific theories.
wow. So they were using these visual tools to express ideas about science centuries before the scientific revolution. That's amazing. It really makes you realize that the way we think about and represent knowledge has such a deep history.
Exactly. Speaking of revolutions in knowledge,
Okay.
I think it's time we shift our focus to the European Renaissance
All right.
and a game-changing invention that really democratized knowledge and fueled an explosion of scientific thought.
Oh, wow.
The printing press.
Ah, the printing press. It's like the internet of its time, right?
Yeah.
Instant access to information.
For some people.
At least for those who could read. I bet that had a huge impact on the pace of scientific discovery.
Absolutely. Think about it. Before the printing press,
Yeah.
knowledge was basically locked away
In, like, libraries?
in monasteries and universities, only accessible to a select few.
Right.
But with the printing press, scientific texts could be mass-produced
Okay.
and spread far and wide, reaching a much larger audience.
So we're not just talking about a few scholars in ivory towers anymore.
Oh, not at all.
It's like the printing press unleashed this flood of scientific ideas into the world.
Exactly.
What kind of impact did that have on who was doing science and how they were doing it?
It led to a huge increase in the number of people engaging with science,
Really?
both professional and amateur.
Hmm.
You start to see the rise of practitioners,
Cool.
like clockmakers, instrument makers,
Right.
and surveyors,
Got it.
highly skilled individuals who are crucial in taking scientific theories and turning them into tangible tools and technologies.
Hold on, I'm seeing a connection here.
Tell me.
Earlier, we were talking about that gap between theory and practice in some ancient cultures.
Yeah.
It sounds like the printing press,
Uh-huh.
by fostering this community of practitioners,
Yeah.
actually helped bridge that gap in Europe.
You're absolutely right.
Interesting.
And it's not just Europe.
Oh, really?
This boom of practical knowledge spread to America as well,
Okay.
where it evolved into what we call Yankee ingenuity.
I see.
We see striking parallels between the skilled artisans of Europe
Yeah.
and the innovative tinkers of the American frontier,
Mm-hmm.
all eager to apply scientific principles to solve real-world problems.
That's cool.
Which brings us to an important question that a lot of people ask.
Like what?
What exactly is the difference between science and technology?
Yeah, I think there's this misconception that technology is just applied science, right?
Yeah, I hear that a lot.
Like science comes first and then technology is just the practical stuff that comes out of it.
Right.
But it sounds like it's more complicated than that.
It's definitely more nuanced than that.
Yeah.
Both science and technology are incredibly creative endeavors,
Okay.
but they require different skills,
Uh-huh.
motivations,
Yeah.
and ways of thinking.
So it's not a one-way street where science always leads to technology.
Exactly. I see it as a dance of weak and strong interactions.
Interesting.
Sometimes science leads to new technology directly, and sometimes technology pushes science forward. They often develop independently,
Okay.
but occasionally intersect in ways that lead to major breakthroughs,
Like what?
like the invention of the transistor or the discovery of penicillin.
Okay.
It's that interplay that's really fascinating.
Okay, so they feed off each other sometimes in unexpected ways. I'm starting to get a clearer picture of this back and forth relationship, but I'm curious about something else. We've been talking about this exponential growth of science,
Yeah.
but can that really continue forever? Is there a limit to how much science we can do?
That's a great question.
I mean, resources are finite, right?
Yeah, they are.
And at some point, it feels like something has to give.
That's a question a lot of people were asking in the mid-20th century,
Really?
and for good reason.
Why?
The sheer amount of scientific research being done was becoming overwhelming.
Seriously.
You've got to remember, the number of scientific journals was increasing at an alarming rate back then,
Oh, wow.
doubling every 15 years or so.
You're talking about the information problem everyone was worried about, right?
Yeah, exactly.
The fact that scientists were having trouble keeping up with all the new research being published.
It was a lot.
It was like a tidal wave of information, and it's only gotten bigger since then.
Right.
So where does that leave us?
By the middle of the 20th century, it was clear that this exponential growth was pushing us towards a state of scientific saturation.
Hmm.
We were facing, and continue to face, some tough questions.
Like what?
Can we realistically keep throwing more money and people at science indefinitely?
Right.
And if not,
Yeah.
what are the implications for the future of scientific discovery?
So we're not just talking about journals and papers here, are we?
No.
This scientific saturation thing, it's about the people doing the science too, right?
Exactly. The number of people working in science has been doubling at a similar rate for centuries.
Mm.
So you've got more scientists producing more research, which leads to even more specialization.
Yeah.
It's a cycle that feeds on itself.
And if we were to graph that over time, it would look just like that graph of scientific journals we were looking at earlier. It all points to the scientific enterprise becoming more and more complex.
Precisely. And that has some pretty significant implications.
Hmm.
For one thing, it makes you wonder if groundbreaking discoveries are actually becoming harder to make.
So instead of having a bunch of scientists all working together on some new breakthrough, like what happened with X-rays, for instance, we now have.
A much smaller group of highly specialized experts, most of whom are already stretched thin, juggling tons of projects and research interests. It raises the question, are we losing that cross-pollination of ideas that's always been so essential to scientific progress?
Right. As science gets more and more specialized, it feels like it would be harder for scientists to see those connections between different fields. Almost like we're risking a scientific community that's fragmented and siloed with everyone working in their own little corner of the universe.
That's a valid concern.
Yeah.
And then there's the issue of funding. Can we really keep throwing money at every promising area of research, especially when resources are limited? I mean, if economic growth isn't keeping pace with scientific growth, something's got to give.
It sounds like we need a more strategic approach to funding science then. It's not enough to just say, science is good, let's fund it all. We've got to make tough choices and think about the long-term implications of those choices.
I think that's where studying the history of science can be so valuable. By understanding the patterns of scientific growth and recognizing the factors that led to both success and failure, we can make smarter decisions about how to allocate resources.
It's like using the past as a guide to navigate the future of science. But I'm also thinking about the human side of this whole scientific saturation thing. You're saying the number of scientists doubles every 10 to 15 years, but can the human brain actually keep up with that pace?
That's a question that's been debated for decades. It's one thing to train more scientists, but it's another thing entirely to equip them with the skills and knowledge they need to handle the increasing complexity of modern science.
It's not just about quantity, it's about quality too, right? You can have a million scientists, but if they're not asking the right questions or don't have the deep understanding needed to make those big breakthroughs, what's the point?
Precisely. And one of the fascinating things that emerges from the research is this idea that the growth of truly groundbreaking scientific discoveries actually follows a different pattern than the overall growth of science.
Okay, I'm intrigued. Tell me more about this. What's the difference in these patterns?
Well, while the number of scientists and publications might be doubling every 10 to 15 years, the number of really significant discoveries, those that truly transform our understanding of the world, those seem to double at a much slower rate, maybe every 30 years or so.
So it's almost like there's this lag time between the overall growth of science and the emergence of those truly transformative breakthroughs.
Exactly. It's as if there's a natural limit to how quickly we can achieve those massive leaps in understanding. It's not just about resources and manpower. It's about those rare flashes of insight, those aha moments that fundamentally change the way we see the world.
It makes you wonder if there's a natural ceiling to scientific progress, doesn't it? Like maybe we can only push the boundaries of knowledge so far so fast.
That's a very real possibility.
Yeah.
You've also got to factor in the role of individual talent, right? We're talking about the Einsteins and Newtons of the world, the once-in-a-generation minds that come along and change everything. Those individuals don't just appear out of thin air.
So even if we have an abundance of scientists, The rate at which we produce truly groundbreaking insights might actually be limited by the availability of those exceptional minds, those scientific geniuses.
It's almost like a bottleneck in the scientific process.
It's a fascinating perspective, isn't it? And this bottleneck could become even more pronounced as science continues to specialize. Think about it. The more specialized we become, the harder it might be for those exceptional minds, the ones who can see connections across different fields to emerge. It's like trying to solve a complex puzzle where all the pieces are scattered across different rooms. You need someone who can see the big picture to bring those pieces together.
This has been such an eye-opening conversation. We've got this rapid expansion of science, increasing specialization, and a potential bottleneck when it comes to truly exceptional talent. That sounds like a recipe for some serious challenges for science in the future.
It definitely presents a unique set of challenges, but I think it also opens up some incredible opportunities. I'm all ears. How can we take all of this vast and complex scientific enterprise, and use it to make the world a better place? How can we overcome those challenges and unlock those opportunities you're talking about?
Well, for starters, one thing that consistently emerges from historical research is the importance of public understanding of science. In a world increasingly shaped by scientific advancements, it's crucial that people understand how science works, what its limitations are, and how to critically evaluate scientific claims.
That's especially important in today's world where misinformation can spread like wildfire. We need a public that's scientifically literate and able to discern fact from fiction.
Absolutely. And that's where I think the history of science can play a vital role. By telling the stories behind scientific discoveries, by highlighting the human element of science, we can make it more accessible and engaging for a wider audience.
It's not just about memorizing formulas and facts. It's about understanding the process of scientific inquiry. The successes, the failures, the controversies, the brilliant minds who shaped the field. By showing people how science actually happens, we can create a deeper appreciation for its role in society and maybe even inspire the next generation of scientists, right?
Precisely. I think we're moving toward a new era of scientific engagement where the public is more actively involved in shaping the direction of research and its applications. This is where things get really exciting. Because at the end of the day, science is a human endeavor, and its success depends on the collective efforts of people from all walks of life working together towards a common goal.
That's a powerful thought. It brings to mind another question that keeps popping up. If we're approaching this point of scientific saturation, does that mean we're running out of things to discover? Are we nearing the edge of human knowledge?
That's a question that philosophers and scientists have been wrestling with for centuries, and it's not one with a simple answer.
Yeah, I figure that might be the case.
But I think it's safe to say that the universe is vast and incredibly complex, and we still have a lot to learn. While certain areas of science might be nearing saturation, new frontiers are constantly opening up.
So it's less about hitting a wall and more about shifting our focus, looking in new directions, exploring uncharted territory.
Exactly. And those new territories might require us to develop new ways of thinking, new collaborations, and new tools. It's about being adaptable and open to new possibilities.
It reminds me of those ancient civilizations we talked about earlier. Maybe the next big scientific revolution will come from an unexpected place, from individuals who are able to connect the dots in ways that we haven't even thought of yet.
I wouldn't be surprised at all. The history of science is full of unexpected twists and turns, and I'm certain the future holds many more surprises. But before we get too caught up in what the future holds, I think it's important to address another critical aspect of scientific advancement, one that sometimes gets overlooked: the ethical implications.
That's a great point. It's easy to get carried away with all the amazing discoveries and possibilities, but we can't forget about the responsibility that comes with scientific progress.
As we continue to push the boundaries of what's possible, we have to think carefully about the potential consequences of our actions. History is full of examples of scientific discoveries that have been both beneficial and harmful. As we navigate this new era of scientific saturation, we need to be even more mindful of the ethical implications of our work.
It's about recognizing that science isn't just a neutral quest for knowledge. It has real-world impacts, and we need to make sure those impacts are positive. It's not enough to just ask, can we do this? We also need to ask, should we do this?
Absolutely. And once again, I believe the history of science can provide valuable insights here. By studying past controversies and examining how societies have grappled with the ethical dilemmas posed by new discoveries, we can develop a framework for navigating the challenges that lie ahead.
It's like learning from our mistakes so we don't repeat them in the future. It sounds like we're talking about a more holistic approach to science, one that integrates ethics history and a deep understanding of the human condition.
I think that's a great way to put it. It's about recognizing that science isn't just cold, hard facts and equations. It's about the human pursuit of knowledge and its impact on the world around us.
This has been an incredible conversation. We've covered so much ground today, from the ancient roots of scientific thought to the challenges and opportunities of this new era of scientific saturation. It's amazing to see how all these threads, from ancient civilizations to the Renaissance and into our modern world, come together to show this bigger picture of how science works and how it's always changing.
It really underscores that science isn't just this straight line of discoveries, but this dynamic, messy process shaped by all these social, cultural, and technological forces.
And that we're not just sitting back and watching it happen, but actively shaping the future of science ourselves. That's a pretty empowering thought, wouldn't you say?
Absolutely. It's not just about inheriting the knowledge of the past, it's about contributing to the knowledge of the future.
Yeah.
And I think that's an important message for anyone who's interested in science, whether they're just starting out or have been in the field for years.
So speaking of starting out, if you could give one piece of advice to someone who's just beginning their journey in the world of science, what would it be?
Embrace the interdisciplinary nature of science.
Okay.
Don't be afraid to explore different fields, to look for connections between ideas that might seem totally unrelated at first glance.
Interesting.
Sometimes the most groundbreaking insights come from bringing together different ways of thinking.
It's like what we were talking about earlier with the Greeks and the Babylonians, right?
Exactly.
That fusion of their unique perspectives led to some pretty incredible advancements.
And don't underestimate the importance of history.
Hmm.
By studying how science has evolved over time, you can gain a much deeper understanding of its strengths, its limitations, and the pitfalls to avoid. It's all about learning from the past so we can make smarter decisions about the future.
It's like having a roadmap, but for science. You can see where others have gone before you, where the dead ends are, and where the most promising paths might lead.
That's a great way to put it. And finally, never lose sight of the ethical implications of your work.
Right.
As scientists, we have a responsibility to make sure that our discoveries are used for good, for the benefit of humanity and the planet.
It's about recognizing that science isn't just a quest for knowledge. It's a quest for wisdom. It's about using our knowledge responsibly and ethically to create a better world for everyone.
Beautifully said. Science isn't just about cold, hard facts. It's about using those facts to make a positive difference in the world.
This has been such a fascinating deep dive into the world of science. I always learn so much from our conversations,
Me too.
and I'm sure our listener feels the same way.
The pleasure is all mine.
Yeah.
And who knows what incredible discoveries await us on the horizon.
That's the beauty of science, isn't it? There's always something new to explore, always another mystery to unravel. Thanks for joining me on this journey.